No. What will be your find the work done by the cell? So what shall we do? Shall we go for distribution of charge method or the nodal analysis? That is what a student has to take a decision here. Like, so already it's a cell, no? Okay, only one cell is there. So little bit, the difficulty in defining potential also will be reduced, no, by very much. So this you can straight away go and write this is 10 volt. Fine. So now how many branches are there? So this is V1, V2, V3, V4. Similarly, what we did earlier, that the same method. Again, the division of charge, you see, like definitely we have to take a risk, that one. We should be very particular about division of charge. Node analysis doesn't need much effort. So at V1, at node 1, I'll write it. At node 1, it will be C into, in exam, no need to write C also, no, directly V1 minus 10, C and will get cancelled out. This will be C into V1 minus V2, C into V1, 3V1 is equal to 10 plus V2 plus V3. At node 2, V2 minus 10, I think 4 capacitors will come there. C into V2 we are taking out, no? V1 plus V3 plus V4. At node 3, C into V3 minus V1, C into V3 minus V2, three V3, this I think now it has some general method, no? Any student can really work out this. It's there's no any difficulty. Solving this will get the required answer.
73.33.
Capacitance, work done by cell.
Sorry, heat generated.
Actually, half of it will go as heat, no?
Sir, half of it will be.
Half of the work done will be heat.
Yes, sir.
Work done, okay, work done by the cell is
46.6.
Yeah, okay, I'll write down. Work done by cell. After this, so what actually you got it? You got the potentials. Again, what is the method? Say the problem is not at all. Okay, don't say you got potential. So that again, just check only the charges. Charge entered, because what all charge enters will here only. So that is what you calculate these two charges. The charge should be pushed by this cell. And the next part of the problem is okay. I'll continue the question here.